Hello, in this video we go over the materials needed for labs 1 and 2, which is the introduction to MATLAB. This video is part 1. Next week we'll go over part 2. First we will talk about the syllabus or where to find it in Moodle. Next we'll talk about the file naming conventions and formatting style in MATLAB, and finally we'll introduce the topics necessary for labs 1 and 2. The syllabus can be found on Moodle. Please read it carefully. It is located at the top of our class Moodle page. We will go over it and highlight some important parts of it during the live lab session. Regarding the file naming conventions and formatting style in MATLAB, a good example for the file name could be lab1. .m is the extension for the code in MATLAB, the code file in MATLAB. Regarding the formatting style that is required for this lab, make sure that you put your name as well as your partner's name in the header of the file as a comment. As extra information or a good practice, you can also include the file name, the date, as well as a brief description of the code. In some cases, you can separate, if you're solving more than one problem in one single file, make sure to comment the code appropriately so that the reader of your code can understand it easily. This is an example of the formatting style. Anything you see in green here is actually a MATLAB comment. Here I put the file name, the name of the class, the date, for example. Here is a code that's written by more than one student. So we say team 1, for example, and the student's name, etc. And since the file solves more than one problem, I mentioned in the code that here we're solving problem 1 and here we're solving problem 2 and so on. So to write a comment in MATLAB, you simply have to put a % or shift and number 5 from the keyboard, followed by the comment that you want to write. So before we start with labs 1 and 2 topic, I have to mention that in this lab we use MATLAB as a tool, or MATLAB code as a tool to solve almost all problems in the lab experiments. Therefore, it is necessary to understand or get very familiar with the skills in MATLAB that are necessary to proceed with this course, which is why we have labs 1 and 2, as well as the MATLAB manual uploaded on Moodle. Please review it carefully and use the exercises of labs 1 and 2, as well as the lecture part, to help you as a guide in future problems. So first of all, what is MATLAB? MATLAB is actually a numerical computing programming language and environment. In other words, or simply put, we can say it's a very smart calculator. It can calculate, plot, compares data, performs different operations on numerical data, and it can also be used to manipulate or process images as well as audio data. The good thing about MATLAB is that it's very easy to use or learn, and it is widely used. A few notes on MATLAB. MATLAB is case sensitive, meaning you have to pay attention to whether you're writing variables in uppercase or lowercase, because for example, an uppercase a is different from a lowercase a variable in MATLAB. And all computation is done in double precision. Labs 1 and 2 are both combined in one single lab sheet. It contains 7 exercises. The purpose of them is to help you learn MATLAB, to give you a start for the future labs. Let's go over understanding MATLAB as a calculator, or how it works as a calculator. Just like with normal arithmetic operation, you have the plus sign to perform addition, minus for subtraction. The second sign here, or the third one, is actually for multiplication, or the asterisk is used for multiplication. We also have the division and the hat for the power. If you want to emphasize the priority of certain operators, you can use brackets. So an example of MATLAB code could be 2 raised to the power 4, 3 minus 2 raised to the power 4. That's the second operation here. The last example is actually 2 plus 3 divided by 4 times 5, meaning we want to perform 4 times 5 first, and then divide 3 by 4 times 5, which is 3 by 20, and then add 2 to that. So knowing or understanding the priority of the operations is very important here. If you ever forget, you can always use brackets, because brackets always have the highest priority. Other operations in MATLAB include the comparison operators such as the greater than, the less than, greater than or equal to, less than or equal to. The equal sign is used when we compare two data to make sure whether they're equal or not. So we'll say A equal B to check whether A is equal to B. If we use one equal sign, this is the assignment operator. It's different from the is equal operator. The last operator here is the not equal. In other languages, it may be the exclamation mark, then equal. In MATLAB, it's simply tilde and then the equal sign. I've mentioned this previously. Comments in MATLAB are preceded with the percentage sign. On the keyboard, it's simply Shift and number 5. It will appear in green. That's how you'll know that this is actually a comment. A good practice or a good way to use a comment is to specify, for example, the unit of numbers, because variables are either strings or numbers, for example. To add more data for the reader of the code to understand your code, you can add that in form of a comment. Moving on to built-in functions. MATLAB has already built-in a library of built-in functions. The most commonly used ones are the trigonometric functions, such as the sine, the cosine, the tangent, the arcsine, arccosine, the arctan, etc. Other functions include the square root, which finds the square root of a number, the exponent, the absolute, which can give you also the magnitude of a complex number, and the angle function, which can give you the angle of a complex number, and the function min, max, and sum, which are used on arrays or vectors in MATLAB to find the minimum value in an array or the maximum value in an array, or to add all the numbers in a given array. So here's an example of using the sine function to evaluate the sine of pi over 2. And the answer we get is 1. Here we're finding the angle of 1 plus I, and this is the answer we got. And in the last command, we're finding the magnitude of 1 plus I using the absolute function. In MATLAB, if you write a command, for example, C is equal to 2 times 4, you will immediately get the answer back from MATLAB, and the answer will be stored in a built-in variable named answer, or ANS. This built-in variable changes its value according to the lastly computed operation. However, if you simply want to save the answer in a variable without displaying it, you must put the semicolon at the end of the command. This is very useful if your computation or if your operation has a very large output, for example, an array of 100 elements. Sometimes you don't want to display the answer right away. You might want to use it to plot later on, or you might want to tabulate it. So using the semicolon can be really helpful to have a very clean or neat command window or output window. In MATLAB, variables can be scalars, or they can also be vectors, meaning more than one element. Another name for a vector is an array. By default, we have row vectors in MATLAB, meaning one single row and one or more columns. To create a variable of type vector, you simply need to use the square bracket to open the array and close it as well. Here I put a semicolon at the end because I don't want to display the variable value. I simply want to store or create a variable with these data. There are two ways to separate items in a vector, either using a comma or using a space. You can use them interchangeably as well. The elements of the vector can be scalars, or they can be function calls, for example, the square root of 2. Okay. Here, vector v has 1, 2, 4, pi, the value of pi, which is 3.14, and the value of square root of 2 as elements. So, for example, I can call the built-in function length on v, and it will give me how many elements vector v has. All right. Here I'm creating another vector named v2, which is equal to, here I'm opening an array using the square bracket, and I'm putting 1 plus 4, and then a space, and then 2. What this will output is actually 1 plus 4 as the first element, and then 2 as the second element. So v2 has length equal to 2. The first element is 5, the second element is 2. So you can experiment with that in MATLAB, and this is what you will get. We can perform operations on vectors, but depending on the operation, sometimes the vectors must have equal lengths. For example, here v2 has length of 2, it has 2 elements. v3 has also 2 elements. That means it is possible for me to add them together. What this will do is actually add the corresponding elements together. It will add 5 plus 1 and then 2 plus 3. So what I will get is a new array whose elements are 6 and 5. You can also multiply the array with -1. That will simply distribute -1 to all the elements in the vector. This will give me -6 and -5. What we just saw is simply adding vectors together, and we said they have to be equal in size. But if we intend on, for example, raising each element in a vector to power 2, then we must put the dot before the operator. This will simply indicate that we want to perform element-wise operation. We said earlier that the power or the hat can be used to raise numbers to certain powers. But if we have a vector and we want to raise each element in that vector to certain power, such as 2, then we must put the dot before the operator. So t dot power 2 will raise each element in t to power 2, or it will square each element in t. 1 dot divided by t, it will find the reciprocate of each element in t. Here we have two vectors, and we're not really multiplying them together. We're multiplying each element in x with each element in y, or each element in x with its corresponding element in y, meaning x and y must have the same size, and the output of this command will give me an array of the same size as x or y, because they're equal, and each element is actually one element from x multiplied by its corresponding element in y. But you have to know, or you have to pay attention to the fact that using element-wise operation, meaning the dot followed by the operator between vectors, will require that these vectors have the same size. All right. Next, we will look at the colon notation. The colon notation has multiple uses. One of its uses is to create row vectors with a specified increment value, specified starting value, and limit. For example, if we say t is equal to 1 colon 3, this will mean I want to create an array starting at 1. If I don't specify the increment value, it will mean the increment must be 1. So starting from 1, increment by 1 until you reach 3, or the limit has to be 3. You should not exceed 3. So 1, increment by 1, I get 2. Increment by 1, I have 3. 3 is my limit, so I will stop here. Okay. If I want an increment value different from 1, I will have to use 2 colons. Okay. At the beginning, I must put the starting value. In this case, it's 2. Between the colons, I will put the increment value. It's 0.5 in this case. And finally, my limit, which is 4. So this will create an array starting at 2, then 2.5, 3, 3.5, and finally 4. Another useful way we can use the colon notation is to extract elements from a vector. So if I have a vector saved in MATLAB named x, and I call x bracket 1 until 3, this will mean I want to get the first 3 elements from x. I want to extract them and output them in the command window. This will mean, the second command, y bracket 3 until 5, means I want to extract or get the elements from y lying at index 3 until index 5. It is now important to mention that the first index in MATLAB is 1. It's not 0, nothing else, it's 1. So 1 until 3 means extract the first 3 elements. All right. If you want to extract or get the last a few number of elements at the end of an array, you will have to call the end command. And in this case, I'm getting elements lying at index number 5 until the end of vector x, from element lying at index 5 until the end of x. The last command will get me the last 2 elements in x, because I'm saying end minus 1 until end. So this will give me the last 2 elements in x. end, -1, and then end. Now we have the transpose operator. The transpose operator is very simple. It simply converts between row and column vectors. So if I have a row vector and I put the transpose operator at the end, it will convert it into a column vector. So if a vector is of size 1 by 3, calling the transpose will give me a vector of size 3 by 1, 3 rows by 1 column. Next, we will look at the plot command. The purpose of the plot command is to plot vectors as a function of another vector. So we'll have to know the x-axis values and the y-axis values. So I have to know, or we have to have two vectors, the x-axis and the y-axis. Here I'm creating the x values as an example. X is equal to 1 until 20. So x is actually 1, 2, 3 until 20, meaning start at 1, increment by 1 until you reach 20. Y is actually dependent on x, and y is equal to 2 times x plus 1. As a mathematic expression, I can say y of x is equal to 2 times x plus 1. Converting this into MATLAB code, this is what we get. Okay, so it's important not to forget the asterisk because this is the multiplication operator in MATLAB. And y of x is simply y is equal to in MATLAB, because otherwise it could mean that you want to extract the x element in y, or the index, the element lying at index equals to x. And that's not what we want to do. What we want to do is simply evaluate an array named y such that it's equal to 2 times x plus 1, meaning 2 times each element in x plus 1. So the size of y will be equal to the size of x. Now to plot y as a function of x, like I said earlier, we have to have two vectors, x and y. Always remember to put the independent variable first. In our case, it's x. Y depends on x because it has x in it in the expression. So we put y afterwards. We call plot x comma y. This will plot y as a function of x. Okay. The rest of the commands are simply to add a title to the plot and to add a label to my x-axis and a label to my y-axis. Remember to use the quotation marks to surround the labels. You could use single or double quotation marks, both will work. So the title of plot is plot of y of x is equal to 2x plus 1. The y-axis label is y of x. The x label is x. The last command will simply add a grid to the plot window, or it will add grid lines so it will be easier to read. And this is optional. In the following session, we will cover subplots, extracting bits from vectors, dot product versus matrix product, loops, user-defined functions, and finally matrices, which is a continuation for what we did today. And this will also help us complete the rest of the exercises in labs 1 and 2 sheet. We covered all the information necessary to solve up to exercise number 4. Remember to use the help command in MATLAB if necessary. So simply type help followed by the name of the command or the name of the built-in function if you want to know more about it. MATLAB will give you all the details about the function, how to use it, etc. Thank you for watching and good luck.